Hello everyone. In this video we will discuss the stack data structure. So a stack is a linear data structure in which elements are inserted and deleted only at one end, which is the top of the stack. If we want to add a new element, we add it to the top of the stack, and if we want to pop out an element, we pop it from the top of the stack. So stack is a last in, first out structure. It's called LIFO because when we want to remove an element from the stack, we remove the last element has been added to the stack. Stack can be implemented using arrays or linked lists. Every stack has a variable called top, which is a location of the topmost element. Also, there is another variable called max, which is the maximum number of elements to be stored in this stack. Here is the operations we can do on a stack. If we want to add a new element, it's called push, and if we want to get an element from the stack, it's called pop. So as we see here, if we wanted this stack now has its top is 1 now. So the top, as we said, the top is the index of or the location of the topmost element in the stack. So now top will be equal, let's start from the first element, which is index number 0, then index number 1, index number 2, then index number 3. So now top is equal to 3. Let's say we want to push a new value, 4 for example. Now 4 will be added to the topmost element, which is 1. It will be added after 1. So now 4 is added after 1 and top is incremented by 1. So now top is equal to 4. 0, 1, 2, 3, 4. Let's say we want to pop an element from this stack. So we will pop the last added element, which is 4. So now 4 is returned and top is decremented by 1. Then top will be equal 3 again. So implementation, we will implement stack using arrays. And here are some properties of the stack. As we said before, top is the index of the topmost element, and top equals -1 of the stack if the stack is empty. So if the stack is empty or we want to initialize the stack, we will make top equals to -1. When new element is added, top is incremented by 1, and when element is popped out, top is decremented by 1. And the max defines the maximum number of elements can be stored in this stack. So here is the implementation of stack using C. Firstly, we defined max was 50. Then we declared an array called stack with size max, and we declared the top. Then we declared some functions like init stack and is empty, which will check if the stack is empty or not, and is full will check if the stack is full or not, and size will return the size of the array of the stack. Push will push a new element, and pop will pop the topmost element, and display stack will display the content of the stack. Let's see the implementation of this function. So init stack, as we said before, if top is equal to -1, then this stack is empty. So if we want to initialize the stack, we will set top to -1, and is empty will check if the top is equal to -1, will return 1, else will return 0, and the function size will return top plus 1, because we said that the top is the index of the topmost element, and the index starts with 0, so we will add 1 to it to return the number of elements in this stack. And isFull will check if top is equal to max minus 1, then this stack is full. And push will check firstly if the stack is full, it will return, else we will increase top by 1 and we will add the new element at the top of the stack. If we want to pop an element, we will check if the stack is empty, we will return, else we will put the current top element in temp and then decrement the top and return the temp variable. And display stack is simply traversing the stack and displaying each element in the stack. We will check if the stack is empty, then if it's not empty we will loop through the elements and display each element. So let's try this application. Let's try to display the stack. So it's empty now. Let's push a new item, 1, push a new item, 5, push a new element, 6 for example. Let's display now 1, 5, 6. Let's pop here, the popped element is 6. Let's display now the topmost element is 5. Let's pop, the popped element is 5. Let's display again. Now we have only 1. Let's pop, the popped element is 1. Now the stack is empty. Let's display, stack is empty. Let's try to pop, stack is empty.